Alright class, in this quick video we're going to look at the properties of solutions. Your joke of the day is, if you're not part of the solution, you're part of the precipitate. I'm going to have my tutor Anna here help out with some of the slides here and discussing it.
A solution is a homogeneous mixture of two or more substances. The solute is the substance present in the smaller amount. The solvent is the substance present in the larger amount.
So, homogeneous mixture, homo means the same. You have to have two or more substances that combine together or you have the same solution. Think about a beaker of Kool-Aid. If you put Kool-Aid and water together, and let's say you mix it properly, each sip is going to taste exactly the same. Solute gets dissolved, it's usually smaller. Think about the Kool-Aid powder, would be the solute. Solvent is the bigger one, that would be the water.
A saturated solution contains the maximum amount of a solute that will dissolve in a given solvent at a specific temperature. An unsaturated solution contains less solute than the solvent has the capacity to dissolve. A supersaturated solution contains more solute than is present in a saturated solution.
So, in this one, let's say I have sodium acetate. Sodium acetate is sodium with essentially almost acetic acid like vinegar. If I take sodium acetate in this beaker and then I combine it with the water, over time it makes a supersaturated solution. That's where you see the crystals forming over here. That's because you have more solute that it will normally fit into the solvent. In order to get your supersaturated solution, again you have more solute than allowed at a given temperature. The supersaturated solutions are unstable. That means that they don't remain in that area that long. If a small crystal is added, then the excess immediately crystallizes out. That's how you can make rock candy with rock sugar crystals. I did that in a lab earlier this year, and you could actually create more crystals forming. That's what I just saw in the sodium acetate solution. Main property that makes solutions combine together is the term like dissolves like. So if you have a positive and negative ends, they're going to typically dissolve each other. If you have non-polar molecules, that means they share their electrons equally, like CCl4 and C6H6, those will combine together. Polar molecules, that means they have slight positive and negatives, will mix with slight positive and negatives. Also ionic compounds usually are more soluble than polar. Think about adding salt and water, they combine very easily. Main one to see is if you have oil and water, think about oil and vinegar in your dressing, they don't mix properly.
Solid solubility and temperature. Solubility increases with increasing temperature.
So if you look at the graph here, most of the curved lines show when you increase your temperature, you're also increasing your solubility. Now the reason for that is it has more kinetic energy in the particles, the molecules are moving around faster, so when they combine together, they're going to connect with each other more, and that's what makes them more soluble. When you're using, say, tea, if you want to make tea with water, you're going to take water near boiling, then you put the tea bags in there, more of the tea leaves are going to extract out from the water, and that's how you get a stronger tea.
Gas solubility and temperature. Solubility usually decreases with the increased temperature.
For this one, think about a Coke can. If you're in a car in Texas in the summer, when it's really, really hot and you open the can up, it's going to fizz out more. That's because the solubility will decrease. It's the exact opposite of what a solid does. Solids typically increase. The reason for this is the amount of dissolved solute in the gas typically escapes as the energy of the water increases. This shows the solubility chart on your periodic table. It's on page 3. Soluble compounds will contain all of the following. The ones on the bottom here are also soluble. The exceptions are the ones that have silver, lead, mercury. If you have a soluble compound and they combine together, you're going to get an aqueous solution. So you'll see it as parentheses AQ. If you have one that's not soluble, let's say it's on this side, then you would write S for solid. That's why the joke in the beginning, if you're not part of the solution, you're part of precipitate, that's because you have different compounds combining together. Alright class, so that covers the basics of solubility, solute, and solvents. I also made another video on dilutions and molarity if you check on my YouTube playlist. If you have any questions though, leave a comment down below.